There's a really amazing telemetry comparison at the chapter marker OMG. If you watch nothing else of this video, watch that. You may have seen this beautiful footage of a RocketLab Electron rocket launching out of New Zealand, but this video is more than just launch footage. We'll go into what this rocket actually is launching into space and what makes this little rocket so impressive. Bigger isn't always better. It's not necessarily worse either, but there's a space launch market that which Falcon 9 just can't fulfill. For instance, this launch carries the first 5 satellites of the Kineis constellation of 15 microsatellites, primarily designed to collect IoT data from locations that are historically difficult to get data from. This is typically machinery in locations that are hard to reach but still need to be monitored to make sure that they are operating correctly and efficiently. Think of turbines in offshore wind farms, pumps along pipelines that span rugged areas, or vehicles that could be traveling anywhere. This market doesn't need to be able to stream 4K videos like Starlink customers do, but instead just enough information for the device to report that it's operating correctly, or not. So to build this type of constellation, it's not really feasible to put a bunch of microsatellites on one rocket when they all need to go to different orbits. It's tough to tell the scale of the rockets in these videos, but this rocket is only about as tall as a 5-story building, and the combined weight of the satellites is less than a sumo wrestler. For comparison, each Starlink V2 satellite is more than a metric ton, and they get launched 22 or 23 at a time. This is also the only rocket that uses battery-powered turbopumps. A full-flow stage combustion engine like Starship uses is very efficient but also very complex. For a small rocket, a lot of the complexity can be removed by simply using battery power. On larger rockets, however, the batteries end up being too heavy to make sense. Now that you've learned something about this rocket, let's watch it take off.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. Beginning pitch over.
Here where they show the telemetry, it's interesting. At T plus 30 seconds, it's only slightly higher and barely faster than the Falcon 9.
For Kineis. Now up next you will hear the call out for max Q, or maximum aerodynamic pressure, which is the point in flight when Electron experiences peak structural loads. The GNC operator on console will give us the call that max Q is approaching, and then we'll listen out for confirmation of that.
Max Q. Cleared max Q.
This blew my mind when I was putting the video together. Max Q is at the same point for both rockets. The speed of sound at this altitude is about 1,000 kilometers per hour, and 12 kilometers is about the height that commercial airlines fly. Both the rockets have been supersonic for quite a while now, and the air must be thin enough at this point that the bow shock in front of the rocket starts to reduce.
MECO is when all 9 Rutherford engines shut down simultaneously on the first stage to prepare for the next phase in flight. Then after those engines are off, Electron's first and second stages will separate. Stage 1 will return back to Earth, while Stage 2 heads in the opposite direction and onward to orbit. Then the vacuum-optimized Rutherford engine on Electron's second stage will light up to propel the stage for this second phase of flight. Now those 3 events all take place in quick succession over just a few seconds, so let's listen in for the calls.
15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
MECO is also at about the same time, T plus 147 seconds. I'm not exactly sure why, but it seems like there's a fairly standard path to orbit including staging. If you know why this is, please leave a comment. I'll keep an eye out for another rocket that shows telemetry to see if this pattern stays up. And as always, please like and subscribe. It really does help.